really big guy in computing. He wrote the book called The Mythical Man Month and came up with the rule that if you add people to a late project, it just gets later. He also was responsible for making a byte 6 or 8 bits instead of 6 bits so that we could use lowercase letters. So that was really interesting to me, something I found out. But later on, we got interested in virtual reality. So in this particular paper, he's talking about virtual environments, especially for scientific visualization. I do work in virtual environments, so that's how I kind of stumbled onto this paper. In this paper, he has this quote, and he says, "We graphicists choreograph colored dots on a glass bottle so as the fool eye and mind is seeing worlds that are not and can never be. Riding Star Tours at Disneyland," which is evidently a virtual reality kind of attraction, "shows how stunningly far we have come. But we must nevertheless ask, are graphics just for fun? Is all this technology for entertainment only? Or worse, for enthralling the mind while a sales message insinuates itself? Surely not." So Dr. Hodges just presented something that goes beyond this. Obviously, we can use virtual reality for better things. So what should these graphics be used for? Well, he says, even today, computer systems help designers visualize electronic chips, mechanical objects, and buildings under design. This potent tool has equal promise in man's ongoing scientific enterprise, the understanding of the physical universe. So he's talking about scientific visualization here, but if you distill it down to the big idea, I think what he's saying is that we should use the things we have to serve the broader scientific community, or just the community in general. So what's community service? It's voluntary work intended to help others, especially those who may not be able to accomplish the task by themselves. So you think about things like breaking leaves, or building houses, or picking up trash. But I think that our discipline does serve the community. How does it do that? Well, a very simple idea is just operating systems in themselves. If we didn't have operating systems, would anyone be able to use a computer besides maybe us? I don't know that I'd even be able to use a computer without an operating system. Probably not. Beyond that, we do things to help people with handicaps use computers. That's community service. We do things like scientific visualization, simulation, all kinds of different things. And these are ways that computers do serve the community now. But I want to kind of focus the question and say, in our own research, are we being good servants? Because a halfway done job is not, it's worse than having not done it at all. So if you build someone a roof and there's still a leak in it, then it's just more of a hassle because someone else is going to have to go rebuild that roof. Or if you leave a yard half raked, someone else is going to have to come back behind and do the job all over again. So it's better to just not do anything at all than to do a poor job of it, in my opinion. So instead of casting judgment on you all, I'm going to focus it back on myself and say, in my research, am I being a good servant, and how can I judge that? Well, Dr. Brooks gave a good criteria for this. He says that we have to produce systems that are so helpful, so adaptable, so easy, that our scientists will use them as routinely as they today use computer text processing. But he says it's easy for us to fool ourselves into thinking we've achieved this goal, for the highly motivated scientist, for example, a doctoral student, will master any tool no matter how awkward. How many of you have mastered an awkward tool? Many over my lifetime, right? And then he gives this principle which he calls the Chapel Hill criterion, which I have now taken on myself to take on this challenge for every one of my projects. He says our systems must be so simple that full professors can use them.
Yeah, we won't mention any particular full professors, right?
And so fruitful that they will. So a full professor might be one audience, but you can think of this as anyone who's really busy and doesn't have a lot of time to figure out complicated things. So are my projects usable for their target audience? Are they simple so that the people that I'm making for can use them? And are my projects general enough that they can be used to yield good results, not just one small section of something? And honestly, if I reflect on my projects, they're not as they stand right now, partially as a result of where they are in research, but also partially because of things that I'm not doing and I'm not being a good citizen of the research community. I'm working on 2 projects right now. One is, and I think they both have really good potential. One's a system to train nurses how to interview virtual pediatric patients, and another is a system to train nurses how to recognize rapidly deteriorating patients. But as I stepped back and evaluated these, according to these criteria, I saw several patterns that I'm failing to meet. We focused a lot on making them usable for the students who will be using them to learn. However, we have terrible usability for those full professors, the people who will be managing those. There's no extensibility whatsoever, so it's unfruitful. We have one set scenario that'll work, but beyond that, it doesn't. So it's a one-time use kind of thing, and it gets really boring. Also, there's no user-level controls. If they want anything to be changed, they have to dig deep down in the code, which they're unqualified to do. So it's complicated. It's not simple. And it's also terrible usability for my colleagues. I had to work on a portion of one of these projects that I was unfamiliar with, and I could not figure it out. It's written by the person next door to me. So what are consequences of this? So I think there are several consequences. First is that our software ends up extinct after we leave. Because if I don't leave a good enough bread trail for my colleagues to be able to understand it, or for the people who manage it to be able to understand it, it's going to go the way of the dinosaur. It's going to be dead after I leave. And I hate to think that I would spend 5 to 6 years of my life developing this stuff and then it dies after I leave. Also, we end up reinventing the wheel. I can't tell you how many times I've been sitting around the lab and listening to someone describe the exact same problem that I solved 3 months ago, but then when I go back to pull out the code, I realize, oh, I don't even understand what I did anymore. Sorry, I can't help you. You have to solve that problem again. So 24 years later, why are we not taking Dr. Brooks' advice to make it simple and fruitful? Well, I think there's a lot of factors, so it's not just that we're terrible people. One is just that we're not good communicators. We're not good at talking to each other about what we've done and what we haven't done. Another thing is there's not a lot of time. We're under such pressure to like get things done, get things done, get things done. We think, oh, I'm just going to throw this together and make it work, and I'll go back and fix it later, and then we never go back and fix it. And lastly, I think sometimes we're just downright prideful, and we think that we're going to understand it, and we know what we're doing, and we should probably honestly step down off our pedestal sometimes and really think about what we're doing. So how can we get better? Well, I think there are some things. First, I think we should be kind to our fellow programmers, and what I mean by that is always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. So, if we would follow this principle, I think our code would actually be a lot better, because you know how frustrating it can be to even find your own code. I did steal that quote, I ran across it. I think it's a good principle. Someone's going to have to maintain your code, whether it's you or someone else. So even if you're very selfish, make life easier for yourself and make your code easy to maintain. Think, plan, and design before you code. I promise, at least in my experience, if I sit down and think and plan, it takes me a shorter amount of time to code. Sometimes we're just so excited about an idea, we just want to jump on it, but if you stop and plan, it's going to pay off in the long run. Write your code to be clear, not clever. We know you're all great computer scientists that can make all kinds of fancy things, but if no one can understand it, it's no use. Also, write for reuse. Make your code fruitful so that other people can use it after you're gone, and you can use it in other projects. I think you also need to empower the people who are the full professors, those people who are going to be managing your program, because they're the users who will have to put up with your system the longest, and they're the ones who determine how long your software is going to be used. If it's frustrating for them, if they don't like it, it's not yielding them results, then they're going to make it die. So you should watch out for them. You can also increase fruitfulness and support simplicity by providing good authorship tools. So that's what I'm working on with my projects right now, is trying to figure out how can I put the authorship in the domain of the people who are actually going to use these simulations so that they can change them and make them different instead of having to come through me every single time. Because like I said, eventually I'm going to go away and they still need to be able to use this system. I think we also need to build on the work of others. I think we need to read before you design. So before you just come up with this great idea and implement it, read a few papers, see what other people have done. I think you should test before you assume. So you might think something's a really good idea, but it ends up not being a good idea. For example, in one of my projects, we thought it was a good idea to use a touchscreen to interact with the virtual hospital. Turns out it wasn't. Clicking one in every single category, including user preference. So we just need to test those assumptions. And we also need to be humble and not think, oh, my project is so different from everything else in the entire world that obviously none of this previous research we've been building for 40 years can apply to it. Mr. Brooks had something to say about this. He said, in watching many awful interfaces being designed and in designing a few, I observed that the uninformed and untested intuition of the designer is almost always wrong. Overgeneralized findings from other designers' experience are more apt to be right than the designer's uninformed intuition. So surely someone has done some work that roughly applies to yours. I keep this on a sticky on my desk to remind me. So I think the last thing we can do is to contribute our work so that others can build, whether that's inside your own work group or on the internet or however you can. When you publish, write for replication of results. All the other sciences do this, and because of this, they can build on other things. But I can't tell you how many papers I've read that I've been trying to implement their technique, and I can't make heads or tails of it. We need to be precise in our writing. And I've read some really good papers, too, actually coming from Dr. Brooks' lab and his colleagues that are perfect. Just, step by step, you can replicate the results, and they're great. Also, make pieces of your project available to others. Like I said, whether it's within your own working group or on the internet or however you can do that, share with other people because that will let them do greater things than you've done. Some of the take-home points, I'm just going to summarize real quick. Why should we think of our research as community service? Because if done correctly, it has the potential to make life easier for our peers, collaborators, and eventually the general public, hopefully. Are we being good servants? Are our systems so simple that our target audience can use them and so fruitful that they will? I know I personally have room for improvement. And lastly, how can we be better at serving others? We can be kind to our fellow programmers, we can empower our full professors, we can build on the work of others, and we can contribute our work so others can build on it. And that is it. Does anyone have any questions?
I've never really thought about designing for a full professor. I'm sorry. I mean, when I think about a full professor, I just think, well, I guess they'll have another student come in. And I mean, it's true, I really don't even think about the student after I leave. I mean, so that is something I can do better on, is commenting code and making it readable for others.
How many of you have ever been that student who comes in after onto another project? How miserable is it? It was very miserable for me.
Right.
So, be nice to your future. Anything else? Okay. Thanks.
Thank you.